Thank you very much for attending my lesson today. And my lesson today is curve sketching on this topic, differentiation. In order to draw a curve, we need to find the coordinates of a number of points from the given equation and plot the points. In this way, an accurate drawing is made of part of the curve. But some characteristic features of the curve may be missed out because they may occur beyond the range of the points plotted. When we sketch a curve, we are to show all the characteristic features of the curve. And an accurate drawing is not necessary. What is of major importance is the information concerning the stationary points and the axis crossing points. Find the stationary points and sketch the curve of y raised equals to x raised to 3 plus x raised to 2 minus x. Solution. You will be required to find the dy dx of the equation. And in this case, the dy dx of this equation is 3x squared plus 2x minus 1. And as we discussed, at the stationary point, the gradient function or the dy dx always equals to 0. Hence, you equate the dy dx of the equation of the gradient function you got, 3x squared plus 2x minus 1 equals to 0. And the formula method, you have x equals to minus b plus negative root b squared minus 4ac over 2a. Where a equals to 3, b equals to 2, and c equals to negative 1. Substituting in the equation, you'll find that x equals to negative 2 plus negative root 2 squared plus 4 times 3 minus times 3 negative 1 over 2 times 3. Solving the equation, you'll get that x equals to negative 2 plus root 16 over 6. Then, when you get the root of 16, you'll get the equation equal to negative 2 plus or negative 4 over 6. So solving for x will give us a third or will give us negative 1. So x has two roots. One is a third and another one is negative 1. When x equals to 1, negative 1, then y you substitute in and you get the value of y. You'll get the value of y equals to 1. And when x equals to a third, then y equals to 5 over 27. So we have find the coordinates of x and the coordinates of y in this equation. Then we proceed, we don't stop there. We move on to determine the nature of these turning points. When x equals to negative 1, because that's one of the turning point, when x equals to negative 1, and when you move to the right, you will get 0, and when you move to the left, we have 2. So the dy dx at 2 is 7, and the dy dx at negative 1 is 0. At 2 it's 7, at negative 1 is 0, and at 0 is negative 1. So when you look at this equation, when you do the diagrammatic presentation of the curve, you'll find that the curve will rise, become constant, then it will fall. Then this one is a maximum point. we find that the dy dx at 0 is -1, the dy dx at a third is 0, and the dy dx at 1 is 4. So when you try to sketch the curve and represent it diagrammatically, then you'll find that the curve will drop constant, then it will start rising again. So this one is a minimum. We have to find the points at which the curve cuts the y-axis and the x-axis. So when x equals to 0, y equals to 0. Then when y equals to 0, when after substituting, you realize that you get that x at 0 equals to x cubed plus x squared minus x. Then you do the factoring out of x, then you get x bracket x squared plus x minus 1 equals to 0. Then x equals to 0, or x squared plus x minus 1 equals to 0. Solving this equation by formula method, it's a quadratic equation, and we solve it by formula method. You substitute where a equals to 1, b equals to 1, and c equals to -1. You substitute properly, and you'll be able to get x equals to 0.62, and also x equals to -0.62. Now, when you put all these coordinates together, when you are able to plot, you can be able to see on the other point where the x-axis is cutting, where the curve is cutting the x-axis, and also you'll be able to see where the curve is also cutting the x-axis. At the beginning there, the curve is cutting the x-axis at -0.62, and it's also cutting the x-axis at 0, 0, and it's also cutting the x-axis at positive 0.62, and the y-axis of course is 0. And now the turning points, you see it's -1, 1, and a third, and 5 over